My name is Professor Ange Davis, and I'm Director of Digital Transformation in Healthcare Education at the University of Manchester. And I'd like to talk to you about educating the healthcare workforce to support digital transformation. Eric Topple, in collaboration with colleagues at Health Education England, undertook an extensive review published about 2 years ago now, which outlines the professions and types of education and training that would be needed to prepare the healthcare workforce for a digital future. Since this time, we've been working at the University of Manchester with colleagues at Health Education England to develop a portfolio of training to address these particular training needs, which I will outline in this talk. Our approach to creating education to support digital transformation really aligns with the 5 key digital literacy domains as outlined by the GIST framework. So firstly, we want to enable the workforce to be proficient in their understanding of the importance of quality and accurate entry of data into electronic health records, with the growing use of this data to develop machine learning algorithms and enable clinical decision support. Capturing of inaccurate and poor data will mean rubbish in and rubbish out. The development of digital champions and super users will mean that digital technologies are developed in an agile way and incrementally, which ultimately will mean quicker updates and much better outcomes for patients. Current analysis and literature has shown that there are gaps in current provision in our education that address the more technical proficiencies in e-health. Suppliers of electronic health records train a small section of the workforce, often missing the workforce that are in training. Our approach to interprofessional education will transcend undergraduate, postgraduate education and professional development of the current workforce. And this sharing of best practice across these particular domains will help to develop communities of practice. In order to build capacity in the right areas in the workforce, we need to develop capability frameworks that educators and professional bodies can use to underpin curricula and training and education. We've been working with Health Education England to develop a capability framework in the area of AI and digital health technologies. We've approached this using a rigorous methodology, including a systematic literature review, a series of workshops using nominal group technique and voting, incorporating views from digital champions, industry, and academic thought leaders. Then finally, to refine the draft framework, a digital survey is being used to seek additional feedback on the framework. The findings of the systematic review were consolidated to a concept map, which was presented to workshop participants ahead of attendance. On the left of this slide, you can see some of the key areas that came up under legal and ethical considerations, for example, and these included ideas such as digital identity, bias in models, and data ownership. During the workshops, a number of additional capabilities were added, which were refined according to individual professions' needs and also what the entire workforce would need. For example, you can see that the issue of data transfer, storage of data, and use of data was felt to be important to understand across all healthcare professions. The final refinement of the framework is currently underway, and we're seeking feedback via an online survey. In 2020, we developed and launched a new massive online open course in collaboration with Health Education England. Our aim was to raise awareness with the healthcare workforce around artificial intelligence and also promote discussion around this topic. We wanted to explore the challenges and benefits of AI and demystify the black box connotations surrounding it. The course was designed and developed and delivered by a multidisciplinary team, including educationalists, content matter specialists, and learning technologists. The course is delivered via the FutureLearn MOOC platform and therefore embeds social learning throughout the course, which is constructed around short videos, case studies, and glossaries. So did we get people talking about AI? To date, we've had over 8,000 participants join the course. In the first iteration of the course attracted 1,980 comments, so we certainly promoted discussion. In terms of did people learn something, of 201 people that responded to the end of course survey, 93% that they gained new knowledge and skills, and 70% said that they shared that learning with other people. Of course, learners always want more, and they wanted more, including more case studies, more detail on the machine learning algorithms, and much more practice, and many more practice-based examples. We've also worked with Health Education England to develop a blended course on machine learning in service design and delivery. This course has been designed for the TOPL Digital Fellows. These are all undertaking a digital technology project within healthcare. The course was co-created with the Digital Fellows, and their requirements for the course were captured, which helped us to hone our course content. We've worked with academics at Manchester who are leading translational research projects to develop case studies for the course. Here you can see a case study that was built around Aspire. This is a service that's been developed to automate the detection of vertebral fractures in CT scans and commercialised by Optasi Medical. The objective of this algorithm is to increase accuracy and efficiency by analysing routinely captured image data from CT scans. By integrating real-world case studies, the fellows can see how this kind of digital technology can be translated into healthcare. The course contains background materials designed and delivered using Articulate Rise, and also integrates Jupyter notebooks to deliver data science and machine learning content. The environment can be accessed from anywhere as long as there's web access, which gives the flexibility to our healthcare professionals to learn wherever they want. The notebooks also allow easy navigation of course content, including background information, diagrams, Python code, and integration of the correct answers for the learners to try when they add code to the notebook. At the end of the course, we did a short evaluation. The fellows enjoyed learning about the different types of machine learning that they might use. They really embraced the human factors and the need to consider the people and the bigger system in terms of readiness for implementation of machine learning. They wanted to find out much more about how to integrate this course into practice. We're running this course again with the second cohort of TOPL Digital Fellows and have integrated an additional case study focusing on the human factors side of things, and the number of Jupyter notebooks have been increased that the fellows can choose from, which enables a much more personalised learning experience for them. So we've made significant inroads to working with the current workforce to support digital transformation. And we're also working on the development of a new clinical data science postgraduate programme to extend this provision. We're very aware, though, of the gaps that still exist in our undergraduate programmes to prepare our undergraduates for the increasingly digital workplace that they'll be encountering. And we are working in particular to develop a programme of education related to electronic health records that we can use across our undergraduate programmes. Finally, I'd like to thank all of my colleagues at the University of Manchester who've worked with me on these projects. Our sponsor at Health Education England, Hatim Abdul Hussain, and also here's the links to our Future Learn MOOC, and you can follow me on Twitter and there's my contact details. Thank you.